For the next three problems, we're going to take a look at the angle of elevation and angle of depression, the ideas of those. And so for 13, I've kind of got a preliminary situation drawn up here. You're going to have to fill in some information here in order to solve it. But, the basic information is that we have a guy and he wants to measure the height of a tree on his property. So it says that he stands 100 feet away from his tree. So we can represent that in here as, this distance, 100 feet. It also says that from his eyes, he measures an angle of elevation of 56 degrees to the top of the tree. Now, if you remember about angle of elevation and angle of depression, we always measure those angles compared to our horizontal line of sight. So if he was looking straight at the tree horizontally, and then he changes his line of sight to look at the top of the tree, that's where that angle of elevation is going to be. So the problem says that this angle of elevation is 56 degrees. Now the picture doesn't have to look correct as long as we have the correct information in it. That's what really matters. All right. Now, if the distance from his feet to the base of the tree is 100, that would also match the distance from his eyes to the trunk of the tree. All right, now what do we need to know? We need to know how tall the tree is. Now, it did give us one other piece of information, and that is that the height of this guy's eyes is 5.75 feet. Now, that's important because if you look at the triangle that's being formed here, the other side of this triangle is not really going to be the entire height of the tree. There's that missing part down here that we're going to have to add in at the end. That's that 5.75 feet, because whatever the height of the person is up to their eyes, that's going to be the same as what this distance here would be. All right, so we just need to solve out this part. That's the unknown part right there. So we do have a nice right triangle formed. That right triangle has one side length given and one angle measure given. And so this is going to be a sine, cosine, tangent problem. All right, so let's set up the relationship and see if we can solve. 56 degrees is the angle that we have. So given that, the side that we're looking for is the opposite side from the 56 degree angle. The side that we already know would be the adjacent side. So which trig ratio uses opposite and adjacent? That would be the tangent ratio. So we can set up a tangent relationship. Tangent of the angle, 56 degrees, would be equal to the opposite side. We'll call this x. So the opposite side, x, divided by the adjacent side, 100. And this is an easy solve. We just have to multiply by 100 on both sides. So whatever 100 times the tangent of 56 is, that's going to be our x value. Use your calculator to get that value. It comes out to be 148.3 if you round it off to the nearest tenth. Now that's actually not our answer, because we have to remember that there's that little part that we haven't added in yet. So x is 148.3, but we have to add in the 5.75. So the final answer is going to be what we solved plus the height of the person up to their eyes. So 148.3 plus 5.75 would give us a final answer of 154.1. All right, let's move on to the next problem, see if we're going to be working with an angle of elevation or an angle of depression. All right, in question number 14, we have an observer in a hot air balloon that's flying 500 meters above the ground. So here's my hot air balloon. I'll just go ahead and put in the 500 meters part here. says that this observer sights a car parked on the side of a road at an angle of depression of 19 degrees. So this is the part where that can sometimes be confusing. So our observer is up here in the basket of the balloon, and I'm just going to draw the horizontal line of sight for this person. If they were looking straight out horizontally, that's where they would be looking. So remember that an angle of depression is measured from the horizontal line of sight. So that means that 19 degrees, when that person changes to be looking at the car instead of looking, horizontally, that 19 degrees does not go in this part of the angle, which is a lot of times where a student might place it. That 19 degrees has to go in that location. Angles of elevation and depression are always measured with respect to the horizontal line of sight. So there's our 19-degree angle, and you can kind of see our triangle set up here. It's not a perfect triangle by any means, but this is also not drawn to scale. So that's our situation. Now, the triangle we're going to be using is this triangle right here. So we do need to figure out what this angle would be. So we know that this angle would normally be a 90-degree angle because of the vertical height of the balloon and then the horizontal line of sight. So all we have to do is subtract 90 minus the 19 degrees to get what this angle would be. So 90 minus the 19 degrees would give us a 71-degree angle right there. All right, so it asks us to find the horizontal distance between the balloon and the car. So obviously they're not asking us for this distance right here because that is not a horizontal line. That would be the direct distance between the balloon and the car. So what they're actually asking us for is, what is this distance? If you drop straight down from the balloon to the ground, what would that ground distance be between the balloon and the car? All right, so I'm going to use the 71-degree angle. If we're looking at that angle, the x would be our opposite side and the 500 meters would be our adjacent side. So once again, we're going to use tangent to solve this out. It doesn't always work that way, but because we're often talking about heights and we're often talking about horizontal distances, tangent does get used a lot in these problems. So we would set it up as tangent of the 71-degree angle is equal to the opposite side, x, divided by the adjacent side, which is 500 meters. And luckily, this ends up being a pretty easy solve again. We just multiply by 500 on both sides. So x is going to be equal to whatever 500 times the tangent of 71 is. You can do this on your calculator, and it comes out to be approximately 1,452, and if we round it off to the first decimal place, 0.1, that would be meters. Now we don't have to do anything else to this answer because that is the answer we're looking for. We don't have to add anything to it or whatever. So once again, we use tangent. Key thing to remember is that angle of depression always goes in the slot that is connected to that horizontal line of sight. Let's move on to our last angle of elevation / depression problem. For this last problem, we've been given the fact that there are two different buildings. The problem stated that the buildings were 200 feet apart, so I've labeled that here. It also says that a woman in building A looks out of a window 30 feet high. So I'm going to mark that window right here. I'm going to go ahead and write in 30 feet right there to remind us that she's already at a height of 30 feet. Then it says she sights the top of the building B at an angle of elevation of 39 degrees. So the woman's horizontal line of sight would be here. And then angle of elevation is measured from that horizontal line. So if she's sighting the top of this building at an angle of elevation of 39 degrees, that's going to be 39 degrees right there. All right. And the question states that we should calculate the height of building B. I think it's pretty clear we have a nice right triangle here. And the distance between the two buildings, the 200 feet here, would also be present at the height that the woman is looking at. So we know that this distance in our triangle is also 200 feet. All right. So let's see if we can set up a relationship that will allow us to solve for this part of the right triangle. We'll call that part x. So once again, if you're looking at the 39-degree angle, this would be the opposite side. That means this would be the adjacent side. And so we are going to use tangent once again. So let's set it up. Tangent of the angle we're looking at, the tangent of 39 degrees, is equal to the opposite side, which is x, over the 200, which is the distance between the two buildings, multiplied by 200 on both sides. So x is going to be equal to whatever 200 times the tangent of 39 is. Go ahead and get that on your calculator. So the value of x comes out to be approximately 161.95. So if we round it off to the first decimal place, that'll actually bump us up to 162.0. All right, now that is not our answer, because just like number 13, that only represents the distance, or the height of the building from the top down to the point where the woman would be looking across horizontally. But it forgets that there's this extra part right here, and that would be equivalent to the fact that the woman is already at a height of 30 feet off the ground. So that 30, this little part right here is going to be equivalent to that 30 feet. So our answer of 162.0, that's the x, and we need to add on that extra 30. We find out that the total height then would be 192.0. All right, that finishes up this section on angle of elevation and depression. The next video will cover the last few problems, which are kind of like some challenge problems and general review for the chapter.